In the grand scheme of things, few concepts have captured human imagination like time and light. These two aspects of reality guide our view of the world, but they also cover mysteries that challenge our understanding of the physical world. Imagine a place where time stops, the clock stops, and the fabric of reality shifts in a direction that defies all imagination. This is not a fictional world, but a world rooted in the philosophy of one of history's greatest scientific minds, Albert Einstein. What if we could use the power of light, the fastest known object in the universe, to explore the farthest reaches of space or manipulate our time? This question has puzzled scientists and philosophers for over a century. In this video, we begin to delve into the complex relationship between time and light, exploring theories of the expansion of the universe, the mysterious phenomenon of time dilation, and the possibility. We unlock the secrets of time travel. As we delve into the mysteries of time and light, an important question arises: does time stop when something reaches the speed of light? According to Einstein's theory of relativity, the speed of light is the final limit to the speed of the universe, a fixed number that nothing can exceed. But now, what is the meaning of the constant and unwavering force that rules our lives? Can time, as we know it, disappear under certain circumstances? The implications of this are fascinating not only for our understanding of the universe, but for the future of human exploration. Could we one day travel at the speed of light or even faster and experience time in ways we never imagined? This video explores these questions and more, revealing the complex relationship between time, light, and the nature of reality. The moon travels at 186,000 miles per second through the vacuum of space. This speed is not just a number. A universal standard by which all speeds are measured. But what does it mean for the moon to move at this speed? When we talk about the speed of light, we mean the speed of photons, the original particles of light traveling through space. Photons are unique because they have no rest mass and can travel quickly without being bound by anything that has mass. This constant speed of light is the backbone of Einstein's theory of special relativity, a theory that revolutionized our understanding of space, time, and motion. According to this theory, the speed of light is the same for all observers regardless of motion. This simple idea is the nature of time and space. Although the speed of light remains the same, time is a different story. According to Einstein, time is not a universal absolute, but a relative quantity that can change depending on the perspective and speed of the observer. This concept, known as the definition of time, is one of the most exciting aspects of relationships. According to the theory of relativity, the faster an object moves through space, the slower time is relative to a stationary observer. This means that time is not an absolute measure, but is woven into space itself, forming what physicists call spacetime. When the speed of matter approaches the speed of light, time changes, leading to the surprising conclusion that time stops at the speed of light. But what happens when we lose the most important time in our lives? To answer this question, let's take a deeper look at the nature of the moon and its relationship with time. For photography, time has no meaning. This may seem strange, but it is a direct result of photons traveling at the speed of light. From a photon's point of view, it moves quickly from one place to another. It doesn't take long since the picture and tube appear. For those of us who live in a world governed by time, it is very difficult to understand this concept. We measure distances in light years, the distance the moon travels in a year, and we know that light from distant stars takes millions, even billions of years to attendance. Come to us, but for the photos that work on this journey, time does not pass. This idea challenges our understanding of time as eternal and indestructible. If time stopped at the speed of light, what would reality look like? Time may not be as important as we think, but is it the wealth that comes from our limited perspective? In order to fully understand the relationship between time and the moon, we need to consider the relationship between time and light. Imagine for a second a situation where the moon has moved. A second has passed for us and we see the moon in the distance. But in photons' eyes, time has not passed. The whole trip was a simple, long event. This uncertainty arises because time is relative, it depends on the observer's frame of reference. For objects traveling close to the speed of light, time seems to slow down and the distance decreases. This phenomenon, known as longitudinal contraction, means that from the photon's point of view, the space it travels through is essentially reduced to zero. The photon does not see the journey as we do. For that, there is no difference between the beginning and the end of the track. This leads us to a good question: can we humans experience this silence in time? Can we reach the speed of light and leave the world of time as we know it? Basically, if someone or something could travel at the speed of light, time would stop in the universe around us. But achieving this is a big challenge. The first hurdle is speed up to 186,000 miles per second. To accelerate a spaceship or a particle to the speed of light, the force must be close to that. Because according to Einstein's equations, mass increases when the speed of an object increases. When an object approaches the speed of light, it has infinite mass and infinite energy to continue its acceleration. This makes it impossible to reach or exceed the speed of light using our current understanding of physics and technology. Another challenge is that even if we could reach the speed of light, it would take a lot of energy for the spacecraft and the human body. Residues and various obstacles prevent us from reaching the light conditions. This means that, while time may slow down for us to approach light speeds, it will not stop. Despite these challenges, the idea of traveling at or beyond the speed of light is not impossible. Scientists are investigating various theories, one of which is the bending or distortion of spacetime. According to general relativity, spacetime is a flexible and dynamic entity that can be distorted by massive objects such as stars and black holes. This gave rise to the concept of reversal orbit, a horizontal propulsion system that could bend spacetime around space, so that it could travel faster than light without breaking the speed limit of the world. By contracting space at the front of the ship and expanding at the back, the starship can propel the star through a spacetime bubble, which can travel great distances in a short amount of time and can be used outside. Let the horizontal state of matter and negative energy density be placed. An alien can be used to establish a wormhole, a structure that connects two distant locations in spacetime. By entering a wormhole, a spacecraft can travel from one place to another at high speed, defying the laws of space and time. Although Einstein's theory of relativity suggests that the speed of light is constant, there are some ways in which light behaves in ways that challenge this assumption. For example, when light passes through different media such as glass or water, it slows down due to interaction with the atoms of the substance. This phenomenon, known as rotation, shows that the speed of light is not a constant value, but varies depending on the environment. Interestingly, experiments in quantum physics have shown that light may not be as perfect as previously thought, especially at the microscopic level. Quantum mechanics envisions a world in which particles such as photons exist in multiple states at once, and their properties are not fully understood until they are discovered. In this vast universe, light is like a probability wave in a stream of particles moving at high speeds. It increases the chance that the speed of light will change under different conditions when the space is created. As we explore these ideas, we come to a provocative question: is spacetime an illusion, as we know it? Some physicists and philosophers believe that the concepts of space and time are not a concept of reality, but a construct of human consciousness. According to this view, what we experience in time and space is a reflection of our mind, a way of organizing sensory information into meaningful information. This view challenges the foundations of physics and shows that the true nature of the universe is outside the known dimensions of space and time. In this sense, light and time are not separate entities, but a close relation of the same principle. If spacetime is still illusory, our efforts to understand and manipulate it may be limited by the way we know it. But even though spacetime is a mere invention, it is still a powerful tool for understanding the universe and uncovering its mysteries. When we come back to the phenomenon of the definition of time, we will see how this effect plays an important role in our understanding of light and time. The definition of time arises because the laws of physics, according to the theory of relativity, must be the same for all observers, regardless of their movements. As a result, time slows down for fast-moving objects and the speed of light remains constant. This effect has been confirmed by many experiments, including observations of particles called muons, which are emitted in the upper atmosphere by cosmic rays. These moons travel to Earth at about the speed of light and, according to our measurements, must decay before reaching Earth. However, over time, their internal clocks slow down, and it takes them a long time to reach Earth's surface. This experimental confirmation of the definition of time demonstrates the validity of Einstein's theory and the importance of understanding the relationship between time and light. If it happens to particles that speed up time, will it happen to people? In theory, yes. If we could travel at the speed of the light, time would slow down for us and those who are still alive. This means that we may be able to travel long distances across the world that seem fast to us, but may take years or centuries on Earth. Called relativistic time travel, the concept has been a staple of science fiction for decades. But achieving such speeds is beyond our current technological capabilities. Even if we can reach these speeds, relativistic effects on time pose a significant challenge. For example, it only takes a few years to travel to a distant star at nearly the speed of the moon, as seen by travelers, but it takes many generations to return to Earth. This disconnect between the time traveler's experience and the duration of time on Earth raises profound questions about the nature of time and the practicality of interstellar travel. As we continue to explore the relationship between light and time, scientists are exploring new ways to manipulate these aspects of reality. One area of research focuses on the possibility of slowing down or even stopping light. In recent years, physicists have developed techniques to trap and slow light in ultra-cold atomic gases, creating a state known as slow light. By manipulating the interactions between photons and atoms, researchers can control the speed of light, effectively bringing it to a halt for brief periods. Although these tests are still in their early stages, they are important clues to understanding and controlling the flow of time. Another avenue of research is the study of black holes and other supermassive environments, where the radiation from spacetime is so intense that light and time travel in ways that are unknown to normal. By studying these phenomena, researchers hope to gain new insights into the nature of time and the ability to manipulate it for practical purposes. Finally, the relationship between time and the moon remains one of the world's deepest mysteries. Despite more than a century of research, we are still far from fully understanding the nature of time or the effects of reaching the speed of light. What we do know is that time is not something fixed and unchanging, but a relative and flexible form of reality that is closely related to the structure of space. As we continue to explore these concepts, perhaps one day we will unlock the secrets of time travel, harness the power of the moon for interstellar exploration, and travel to the region of spacetime or beyond. Until then, the mystery of time and light will continue to inspire wonder, curiosity, and the search for knowledge.